Exponential functions, part 6, Antiderivatives of exponential functions, revision on definite integrals, and revision on areas. First rule, the antiderivative of Ex is Ex plus C, because the derivative of Ex is Ex, so the antiderivative of Ex is Ex plus C. For example, the antiderivative of 4x minus Ex. The antiderivative of 4x is 4x squared over 2, that is 2x squared, and the antiderivative of Ex is Ex. Second example, 6x plus 3 minus 5Ex. The antiderivative of 6x is 6x squared over 2, which is 3x squared. The antiderivative of 3 is 3x, and the antiderivative of 5Ex is 5Ex. Rule number 2. The antiderivative of Eax plus b is 1 over a Eax plus b plus c. Why? Because if we take this quantity and if we make derivative for 1 over a Eax plus b, Eax plus b has the form of EU. And we know that the derivative of EU is U prime EU. So the derivative of Eax plus b is A times Eax plus b. A and 1 over a are cancelled, which is equal to Eax plus b. Then the antiderivative of Eax plus b is 1 over a Eax plus b plus c. For example, here a is 4 and b is minus 1. So the antiderivative of e for x minus 1 equals 1 over a, that is 1 over 4 e for x minus 1 plus c. Other example, antiderivative of e to x. Also here a equals to 2 and b equals to 0. We apply the rule, then it is 1 over a, that is 1 over 2 e to x. E minus x, the antiderivative of e minus x. Here a is minus 1 and b is 0. So the antiderivative is 1 over a, that is 1 over minus 1 Eax plus b, so it is minus e minus x plus c. The antiderivative of e3x minus e2x plus 5ex over ex. First, this quantity e3x minus e2x plus 5ex over ex can be written as e3x over ex minus e2x over ex plus 5ex over ex. That is, here when we have ea over eb, we subtract the powers, so we get e2x minus ex plus 5. The antiderivative of e2x, here we apply this rule. It is equal 1 over 2 e2x, and the antiderivative of ex by rule 1 is ex, and the antiderivative of 5 is 5x plus c. The antiderivative of, here we want to make revision for the integrals. We know that to find the integral, first we must find an antiderivative. then we substitute 1 in this antiderivative, minus we substitute 0. The antiderivative of e3x, applying this rule, is 1 over 3 e3x, and the antiderivative of 8x is 8x squared over 2, which is 4x squared. Substitute 1, we get 6 over 3 first is 2 e3x minus 4x squared. We substitute 1, we get 2e3 minus 4 times 1, minus, then we substitute 0, we get 2e power 0 minus 4 times 0. 2e power 3 minus 4 minus 2, that is 2e cubed minus 6. For example, now we want to make revision on the area. C is the representative curve of the function f, where f of x equals e2x minus 2x. We want to calculate the area of the region bounded between C, the x-axis, the y-axis, and x equal to 1. According to the rule, this area equals the integral from 0 till 1 f of x dx. So, the antiderivative of e2x is 1 over 2 e2x, and the antiderivative of 2x is 2x squared over 2, that is x squared. Now, substitute 1 first, then substitute 0, we get 1 over 2 e power 2 minus 1 minus 1 over 2 e power 0 minus 0, which is 1 over 2 e squared minus half e power 0 is half. So we get 1 over 2 e squared minus 1 minus half, which is half e squared minus 3 over 2 unit of area squared. Now, rule 3. We know that the derivative of EU is U prime EU. So, the antiderivative of U prime EU is EU. For example, 2x plus 1 ex squared plus x. Here we take U as x squared plus x. The derivative of x squared plus x is 2x plus 1. So this function has the form of u prime e u, and the antiderivative of u prime eu is eu. So we get ex squared plus x plus c. Second example, 3x squared ex cubed. Here also we take u x cubed, so u prime is 3x squared. So this function has the form u prime e u, which is eu ex cubed plus c. Third example on this rule, x plus 1 ex squared plus 2x plus 1. Here we take u x squared plus 2x plus 1. U prime is x squared plus is 2x plus 2. If we take common 2, it is 2 into x plus 1. But here we have x plus 1. So as usual, we put here 2. And outside the integral, we put 1 over 2. So this function has the form, u prime e u, and its antiderivative is eu. Then we get 1 over 2x squared plus 2x plus 1 plus c. Rule number 4, integration by parts. We took integration by parts upon integrating some functions with them. remember that the rule is the antiderivative of u prime v equals uv minus the antiderivative of v prime times u. For example, we want to find the antiderivative of x e to x. When we were solving integrals with ln, we took v equals to ln x, while here in the exponential, we take u prime equals to e to x, and we take v equals to x. Now, if u prime equals to e to x, then u equals half e to x, because we are finding the antiderivative of e to x. Going from u prime to u is to make an antiderivative of e to x, which is 1 over 2 e to x, according to rule number 2. The antiderivative of eax plus b is 1 over a eax plus b. So the antiderivative of 1 over 2 e to x is 1 over 2 e to x plus c. Now, go back to the rule. We take e to x is u prime, and we take v equals to x. So v prime equals to 1. Apply the rule, we get u times v minus the antiderivative of v prime times u. Okay, this is v prime, which is 1, times u, which is 1 over 2 e to x. Again, we want to find the antiderivative of e to x. Go back to this rule. The antiderivative of e to x is 1 over 2 e to x, and we have 1 over 2, so we get 1 over 4 e to x. Then the antiderivative of x e to x equals half x e to x minus 1 over 4 e to x plus c. Second way, I will take the same example, antiderivative of x e to x. This way is called tabular integration by parts. I will put a table. In the first column, I will write the polynomial beside the exponential, which is here x. And in the second column, I will write e to x. Now, in the first column, I will make derivative of this polynomial until I get 0. So the first derivative of x is 1. Then I will make the derivative of 1 is 0. While in the right column, I will make antiderivative how many times as the times that I make the derivative. So the antiderivative of e to x is 1 over 2 e to x, and the antiderivative of 1 over 2 e to x is 1 over 4 e to x. Then I will multiply x by half e to x, and I will put before the answer plus. Then I will multiply 1 by 1 over 4 e to x, and I will put before the answer minus. Always I multiply the first item in this column by the second item in this column, and so on. Then the antiderivative of x e to x equals multiply x by half e to x. It is x over 2 e to x, and we put before it plus here. Multiply 1 by 1 over 4 e to x, and put before it minus. We get minus 1 over 4 e to x plus c. Okay. Second example, the antiderivative of x power 4 e minus 2x. Try to make pause on the video and try to solve this antiderivative Now, as we said before, we make a table. In the left, we put the polynomial, which is x power 4, and in the right, we write the exponential, which is e power minus 2x. The derivative of x power 4 is 4x cubed, then 12x squared, then 24x, then 24, then 0. Here to the right, the antiderivative of e minus 2x, it has the form eax plus b, so it is 1 over a eax plus b. So minus half e minus 2x. Also here, minus half e minus 2x, and we have minus half, it is 1 over 4 e minus 2x. Here, minus half e minus 2x, and we have 1 over 4, we get minus 1 over 8 e minus 2x, minus half e minus 2x, and we have 1 over 8, we get 1 over 16 e minus 2x, minus half e minus 2x, and we have 1 over 16, we get minus 1 over 32. And as we said before, we multiply the first item in this column by the second item in this column, and we put the plus. Then we multiply the second item in this column with the third item in this column, and we put minus, and so on, a plus, minus, a plus, minus, a plus. Here we stop because we have 0. Then the result is the antiderivative of x power 4 e minus 2x is x power 4 times minus half e minus 2x minus 4x cubed times 1 over 4 e minus 2x plus 12x squared multiplied by minus 1 over 8 e2x, then 24 times 1 over 16 e minus 2x, and we have before it minus, then 24 times minus 1 over 32 e minus 2x, we get this quantity, and we can take minus 1 over 4 e minus 2x common factor. Now I want to find the area of some function, and I want to use integration by parts. Given the function f of x equals to x cubed ex, I want to calculate the area of the shaded region. Note here the area of the shaded region is the area between the x-axis, the curve x equals to -3 and x equals to -2. But remember that the curve is below the x-axis, so we put the area equal minus the integral from -3 till 2 f of x dx unit square. Now we want to find the antiderivative of this function. The antiderivative of this function is done by the method of integration by parts. So we put here the polynomial, which is x cubed, and to the right we put the exponential, which is ex. Now, derivative of x cubed is 3x squared. The derivative of 3x squared, 6x. The derivative of 6x is 6, and the derivative of 6 is 0. Similarly here, we make antiderivatives. The antiderivative of ex is ex, and so on. Then, the antiderivative of x cubed ex equal, we multiply the first item of the column to the left by the second item of the column to the right, we get x cubed ex minus the second item is 3x squared. We multiply it by the third item, which is ex, and we put before them minus, okay, and so on. So the antiderivative, we can take ex common. It is ex x cubed minus 3x squared plus 6x minus 6. Then we want to find the area after we have the the antiderivative. The area, we take the antiderivative, and don't forget to put the minus. We substitute minus 2, then we substitute minus 3, and we get 38 e minus 2 minus 78 e minus 3 units square.